In this video, we're going to be analyzing this op-amp circuit that involves a capacitor. Now there is a name for it. It's called the differentiator op-amp, and by the time we finish solving the problem, you'll see why that is. Now we don't have any specific values of resistor, capacitor. We don't have a specific input VI. We're just trying to find a general relationship between the input and the output. Well, for ideal op-amps, we know V plus is equal to V minus. V plus here is hooked up to ground, so it's 0 volts, which means V minus is also 0 volts. We're going to go ahead and do essentially a node voltage, really Kirchhoff's current law, at the negative terminal. We know the current going right is 0 amps. That's easy to do. The current going up here, that's going to be the voltage we start at minus the voltage we're going to over R. And then going left here, I'll call this current I. I cannot use Ohm's law for it because it is not a resistor. It is a capacitor, but we do know for a capacitor that the current through a capacitor is C times the derivative of the voltage across the capacitor. We do have to be careful here though, because the voltage across this capacitor, if you think about this is going to one side and this is going to ground to the other side, we can really say the voltage across the capacitor is in fact the same. They're basically in parallel here. So that's going to be VI. But we have a current going into the negative side rather than the positive side, which means we really have I as negative C dV dt here. So by my Kirchhoff's current law, the current going left is negative C dV dt. The current going up is 0 minus V0 over R. And the current going right is 0 amps. Add them up, you get 0. And if you do a little bit of work here, move things over to one side, multiply by R, you are going to have the following here, that the output voltage V0 is equal to negative RC times the derivative of the input voltage. And so what you see here is that this circuit will take whatever the input voltage is, take the derivative, scale it by RC, whatever number that works out to be, and then invert it with a negative sign, and that will give you the output voltage. So this electric circuit here will calculate the derivative of whatever input voltage you give it to. And that's why this is called the differentiator op-amp.